Hey guys, welcome back. So today we're working on the 7,000 watt DeWalt generator. I found this one on Facebook Marketplace for $125. According to the listing, the engine runs strong, but the generator doesn't make power. So the goal today is going to be to get this machine to make power again. So let me get you set up a little bit better and get going on this. So before we dig in too much on the generator side of things, let's just make sure that we have a good engine. Now, someone did take the end cover off already. We are missing the brushes and the AVR. So like that, this machine absolutely will not make power, but that's okay. Right now, I just want to test the health of the engine and make sure we have a good starting point. So first things first, let's make sure we have some oil here. And we do. It's actually filled most of the way to the top. And the oil smells good. I don't think it's contaminated with fuel. And I could hear the fuel sloshing around when I brought this up on the lift. So let's get the filter out and see how much we have, and more importantly, if it's any good. Yeah, I'd say this fuel's been in there for some time. It's not bad yet, but it is really close. So I will test with it, but that fuel definitely needs to be swapped out, once we get this machine fully up and running. Well, the good news is this is an electric start model. The bad news, of course, the battery is stone cold dead. So let's throw a new battery in there real quick, and then we'll crank the engine over and see if the engine shows any signs of life. Can somebody tell me why on the negative they protect it? The whole machine is negative, so don't really need to protect it against much here. Positive you do, but with a battery as dead as this, don't think we need to worry about it too much. And when connecting a battery up, always connect the positive first. That way, if you accidentally bridge between positive and the frame, you're not going to short things out. And the engine still doesn't crank even with a good battery in there. So potentially this battery wasn't even bad. I guess we should test that real quick. But we do have a wiring issue, I would say. And likely it's down here. Actually, some Generacs, they actually pull the ground from the high voltage side of things to trigger the solenoid. So let's get that reconnected and try to crank the engine again. All right, so the battery that came out of the machine, 5.5 volts. So yeah, that definitely wasn't going to crank the engine. Let's double check the new one. All right, let's check the good battery. So the positive wire comes right up to the solenoid, so we'll probe that. And then for the negative, we can pretty much probe anywhere. And yeah, 12.9 volts. So the battery we installed is definitely good. All right, what about now? Okay, the engine cranks. So let me set up a little bit better. We'll get the fuel turned on as well as the choke and try to start the engine. All right, let's turn the fuel on. Choke is already on. So let's crank the engine, see what we get. Now, one beef I have, and a lot of manufacturers do this, is that they put the ignition switch to crank the engine somewhere kind of far away. At least in this case, it's in the middle, but ideally it should be over here or maybe right there, because you need to work the choke. So here we go. And we get nothing. So yeah, we don't have any signs of life here. So the seller said it was a strong running engine. I guess he didn't say when. You know, given the condition of the fuel, I'd say it's been some time, but I don't think we have engine problems. I mean, we actually have very good compression and almost no leak down. So I don't think compression's an issue. You know, likely it is a fuel issue, but let's just check for spark real quick. And assuming we have it, which likely we do, then we're going to have to pull that carb and get it cleaned up. So we'll just use the spark checker. It doesn't guarantee that we have spark on the plug, but it will tell us if we at least have spark going through the wire. So let's crank the engine. And what we want to see is that the OK light lights up green and starts blinking. Okay. And it was blinking okay. Now it's saying hi. But that is a good sign that we have spark. I guess, you know, as a double check, we can check the plug. Wow. That plug is in there. And for whatever reason, there is a little bit of corrosion here around the valve cover. There we go. Wow, that is a lot of corrosion around the base of that plug. The tip doesn't look bad. You know, I was going to test for spark on this plug, but I don't think I want to put this back in the machine. So, you know, this is a Honda clone. Usually they take a BPR 6ES. And this one actually doesn't have any numbers on it other than the name Bosch. So yeah, let me swap that out for a new plug and we'll check for spark. So we're going to use a brand new BPR 6ES. I've double checked the gap. It's right at 30 thousandths. So we'll just get this on the boot. I'll zoom you in and let me know if we have spark. So yeah, we've got good spark, which I'm not that surprised about. These machines usually don't lose spark. And the plug we pulled out of there, the tip was completely dry, which tells me we are not getting any fuel through that carburetor. Yeah, before I get the carb off, I am going to drain the bowl. I'm kind of curious what's in there. And to do that, I actually need to make room. You know, these lines are in the way. And they're almost glued together. But these lines are going to have to come off anyway. I think the tank is going to get pulled when we dig into the generator, because likely we're going to have to pull it off and either fix the generator or find another. Actually, let's just pull off this, what I assume is a charcoal canister. So the fuel valve, it is still on. Let's see if there's anything at all in the bowl. No. And that is not a good sign. If you look at the end of the bolt, it's covered in a very heavy varnish. So yeah, needle and seat, I would say they're stuck. And actually the smell from the tip of that bolt is pretty bad. So yeah, it is heavily varnished. We do need to get that carb off. That is not a good sign. There is a ton of rust on this plate. So I've never seen anything like that before. And the carb itself looks okay. So I'm not sure why that's so bad, yet the plate isn't. And the spark plug was pretty bad too. So this is really weird how just certain parts of this machine have rusted up. Not a good sign. So I'm going to knock some of the rust off the studs. But I don't think this carb's going to come off without putting up a fight. Okay, that wasn't bad. 2 for 2. So the fuel valve, it is still turned on. So let's see if we get any flow from the tank. Yep. So no issues with the line or the fuel valve. And the fuel, I mean, again, doesn't look great, but at least there's no water in that fuel. All right, place your bets. How bad is it going to be? I think it's going to be pretty bad, at least on the varnish front, but I don't see any rust. So whatever's in there should clean up with a bit of degreaser in a little time. In the ultrasonic, although that drain was pretty tight, the bolts with a bowl, and there is actually fuel in there, so the drain is clogged up with varnish. Yeah, a few chunks. No water. But it smells terrible, though. It smells like varnish. There we go. Yeah. Just a lot of varnish. I don't really see any corrosion, so that actually will clean up pretty well. This bolt right here, it's not the main jet, but it is the pickup for the fuel. And it is clogged on one side, but not the other. And the main jet doesn't look great. I would say that is likely plugged solid. Needle was gummy, but it did come out. Looks pretty good. And the main jet, I give almost no chance of coming out. At least until we soak it a little. Oh, it is coming out. There's the main jet. And the emulsion tube, it's kind of stuck in there. There we go. Yeah, main jet is plugged solid. No light getting through there. Emulsion tube actually doesn't look too bad. And sometimes there is a removable jet on the side, but in this case, it's broken off at the factory, preset, so we can't touch that. But we do still have the pilot jet, so let's get that out. You know, likely that is plugged as well. And it's always pretty hard to tell on these. So I'm going to run through everything with a wire, at least clear the clogs. And once that is done, I think a good 10-minute soak, maybe in some Simple Green, should clean this right up. Yeah, pilot jet, surprisingly, was not clogged. And main jet, yeah, it was plugged. You can see some of the junk there that came out, but it wasn't plugged solid. So that should be okay. Don't suspect we have an issue here. I can see through the emulsion tube, but we'll just run through these little holes and make sure. Okay, and then we have the pickup down here. Yep, definitely pretty gummy. And there are some more holes, it looks like, up here. And the center one. So everything's pretty gummy. You can see just a bunch of junk coming out of there. So yeah, we'll give this an extra long soak, but degreaser, it'll rinse that varnish right away. And this carb, believe it or not, should look almost like new when we're done. There we go. So it is important to kind of clear the passages before putting this in the degreaser. Otherwise, it's not going to get into every nook and cranny. Let's see what we're making out. It's only been 5 minutes. And yeah, we're making pretty good progress, but it's going to need at least 5 or 10 more before it's done. All right, so while that carb is cooking away, let's get the old fuel out of the tank. All right, so it cleaned up pretty well. I wouldn't say quite like new. You know, the simple green, it is a good cleaner, but if you leave it in there too long, it does start to turn the aluminum a little bit dark. That said, though, I bet it's going to work a lot better than it did before. So we'll get the emulsion tube and the main jet back in. As well as the float, the needle, and the pin. And the pin's not going in. Let's try it from the other side. No. So we might have to clean the pin up a little bit, although it came out without a fight. There we go. And this generator, it does actually have an auto idle function, which probably doesn't work given that we have no power output. So, you know, if we do fix the generator side of things, we might have to set that. For now, though, only 1 or 2 threads should be poking through. So let's get this back on the machine and see if the engine will start. But first, let's clean some of the rust off these studs. And yes, I pulled the towel out. You don't want to leave that in there, or you're going to create a much larger problem. And I'm going to leave the airbox off for now. So we'll just clamp this down. I'm going to run a fuel line, not to the tank. We're going to feed it some fresh, good fuel, and then try to start it. Okay. We're full, although the fuel, it is still advancing slowly, so either the needle is going to shut the flow off in a second, or we're going to start flooding over. I think we're good. Needle shut off the flow. We're holding steady. So let's try to start it. Okay, so the carb should run the engine now. I guess the question is, how well? So, choke is on. Contact. So I think the answer to that question would be good. That carburetor is actually running the engine perfect. You know, it fired up right away, turned the choke off right away, and the engine ran nice and steady, and it sounded really good. So I don't think we have any issues with the engine. So I think we do need to shift focus here to the power side of things. But before we do that, you know, we do have a little bit of heat in the engine, so let's get the oil changed while it's hot. So the oil, it's definitely darker than I thought it was going to be, but there is no metallic, no sparkles. You know, overall, the oil looks pretty good. So I think the engine is in good health. It is tempting just to throw a set of brushes and AVR on this generator to see what, if anything, we get. And it might come to that, but before we do that, I think we should at least break out the multimeter and run some tests just to see if there's any obvious problem. You know, visually, I don't see a problem, but that doesn't mean we don't have one. So we are already mostly isolated. You know, I think I'm just going to remove the ground, unplug the auxiliary winding, and we'll run some tests, see where it's at. So before we run any tests, let's just fully isolate things. So I'm going to remove the ground connection, and I guess we need to remove these two as well as the auxiliary winding connection. So I'm going to try out a new tool. This is a milliohm reader, and it should be fine for testing the main legs, but I'm not sure if these probes are going to be able to get into every connector we have here. But this is going to give a very accurate read on the resistance. Now on leg 1 and leg 2, we should usually see about 0.3 ohms plus or minus 0.1. In this case, we're at 0.323, so that appears to be good. Let's just check for a ground fault. No issues there. And we'll check leg 2 next. We should see pretty much the same thing. And yeah, 0.332. So that seems good. And no ground fault. So leg 1 and leg 2 appear to be good. And for the rest, I'm just going to use the regular multimeter. Just make sure you get the internal resistance from your probes before you do any tests. You know, in my case, it's 0.1. You know, yours might be a bit higher. So any reading you take here, you can subtract that internal resistance. So we already checked leg 1 and leg 2. You know, they seem to be good, no ground faults, but let's just check them to the other windings. So I'm going to start here with the auxiliary winding. There should not be a connection, and there's not. And then we'll check the DPE winding, which are the blue wires. And there should not be a connection, which is not. So that seems good. We'll check the other leg, same tests. And yeah, those are both good. So let's check the auxiliary winding. I'm not sure what the resistance should be on this one, but it should not be open circuit, and it's not. 0.4 ohms. Check it to ground, no ground fault, and we'll check it to leg 1, leg 2, and the DPE winding. So the auxiliary winding seems to be good. This connector, we have 4 wires, the green and the white, should connect over here to leg 1 and leg 2. And we get a good connection there. Good connection there. And technically we don't need to test this to ground. We already tested leg 1 and leg 2 to ground, and that's where these wires lead. So that leaves us with the DPE winding and the rotor. So the DPE winding usually 1.5 to 2.5 ohms. And in this case, it's open circuit. So yeah, that is a problem. The DPE winding, that is the power source to the AVR, and ultimately the brushes. So if that is open circuit, then that is a very good reason why this generator would not make power. But there are no faults to other windings. It just seems to be a broken wire, likely in the stator. So yeah, that is the problem. Let's check the rotor real quick, make sure that is good. And yeah, 57 ohms. So the rotor appears to be good. And no ground faults. So unfortunately, DPE winding is open circuit. And like that, this is not going to work. At least not like it is. So there are a few things we can do here. I guess first off, because this is open circuit and not shorted to anything else, technically we could apply power to the brushes using a battery, and this generator would generate power through leg 1 and leg 2. We would also get power out on the auxiliary winding, but we would not have an AVR to control anything. Plus, we need a power source, DC power source, to send to the brushes. So that is not ideal. There are universal AVRs. You can actually connect and power right from the main outputs and not use the DPE at all. So that is also an option. My only concern is the DPE winding clearly has had a meltdown or something and potentially may have weakened the rest of the stator as far as the insulation goes. So, those are options. I guess what I'm thinking for now, though, is maybe I'm going to cut these blue wires. Let's test on them directly. If we're really lucky, the failure might be, between the wire and this crimped on connection right here. So let's do that, see if we get the same result. So actually, I'm going to try to release these without cutting it. Using the wrong tool, but if it works, then it wasn't the wrong tool. All right, there's one. Yeah, I don't think we have any problems with the crimp. I see the wire right there on both of these. And the insulation is not part of the crimp. So yeah, I don't think the issue is with the connector itself. So I am going to cut these off. We'll just triple check. But from what I can see, the connectors are fine. Yeah, still open circuit. So the issue, fortunately, is internal to that stator. So yeah, without a doubt, the DPE winding is bad. We need a new stator. But I can almost guarantee you, no matter what stator I put on here, we're not going to have this auxiliary winding. So I did take a look at the wiring diagram just to see what this is powering. And I guess the good news is the idle control circuit, that is powered by the 120 side. So that should work even without that auxiliary winding. And the battery doesn't charge via the generator or that winding. You actually have to plug it in to charge. But we are going to lose the wattage meter and the runtime meter. So on the top of the tank, there is actually a sending unit. So, we could swap that out for a traditional one. Of course, I'd like to save this if I can. So what I'm going to do now is actually just pull these screws and pull the panel forward. I want to see that, is there any information on the unit that powers this as far as its requirements for input voltage. Yeah, unfortunately, I'm not seeing anything here on the board indicating what its power requirements are, but these are the gray wires right here coming in from the auxiliary winding. Now, the real thing of interest here is that the board is actually made by Generac. Anyway, What I was hoping to do was steal a little bit of power from the 120 side, put a transformer to step it down, and then feed it in. But, even if I did that, this is so tight in here, I don't think we'd actually have room to fit a transformer. So unfortunately, that was kind of a dead end, but there is one more thing I want to do before pulling the stator off, and that is actually to get the engine started and supply some external power to the brushes to get this thing to power up. Now, this connector, it's obviously going to be disconnected, which is fine, but I do want to reconnect leg 1 and leg 2 to the control panel, and we'll also probably connect this and try to back probe it and just get a read on what the AC voltage is coming out of that into this panel right here. So I'm just going to add some leads here to the brushes. And the wires on the other end right now, they're connected to nothing. But once this is up and running, we can connect this to a 12-volt battery, which likely isn't going to be enough. So we're probably going to have to get some of those connected in series to bump the voltage up. But 12 volts is a good starting point. And as far as this goes, I did try to back probe it with the multimeter, and I just can't really get in there very well. So, this wire is going to have to be cut if we have any chance of reusing this with a different stator. So I'm going to cut some of this insulation. I'm going to cut the wires, and then I'm going to probe directly on the output. And at the same time, I'm going to feed it up to that board. Just make sure the board itself is still good. Well, I think we're ready. So the multimeter here on the right, that is connected to the output on the auxiliary winding. The meter on the left is connected to one of the legs. So, we're going to get the engine started, apply 12 volts with this battery through a 3-amp fuse right to the brushes. The positive goes on the left. And this should get things to power up, but we're not going to get to full voltage. I'm thinking probably around 30 volts. So if that's the case, we'll make adjustments and keep going until we reach 120 volts. So I think it goes without saying, don't do this. Or if you do, use a lot of caution. In this case, we know the DPE winding is bad. We know the stator's bad. Thankfully, we don't detect any shorts to ground or with any other windings. So theoretically, this should go pretty well. Of course, the danger is with the damaged stator, you might have a complete meltdown and let the magic smoke out, but I don't think that's going to happen here. So I am plumbed in to external fuel, so we don't have to worry about that. So let's give this thing a try. Contact. that was a good test. We got 50 volts out AC from leg 1 and about 4 volts from the auxiliary winding. So, that would suggest that this is probably in the 10 to 12 volt range. And I actually should have focused in on this, but when I kind of panned over to shut it down, I did see the runtime meter said low. So this did appear to be working. So I'm going to try this again, except this time we're going to double the voltage to 24 volts, which will get us close to 100 output. And I'm thinking this should roughly double to about 8.5 volts. All right, let's try this again. Contact. Well, I think that gave me the information I need. This time at 24 volts to the brushes, we had close to 100 volts out and almost 10 volts AC out on the auxiliary winding. So yeah, this I would say does open up some options. We only need about 12 volts AC, and actually it seems to run fine on less than that. So one possibility is that we could put a coil behind the flywheel. And I guess that's a big question mark, because you do need the right kind of flywheel with magnets on it to generate power. So, potentially we could swap the flywheel, put a coil behind there, and feed it right into that, which would give us power. And of course, the alternative might be, to run a transformer or something to step down the 120 to something a little bit more digestible by this meter. So let's get all of this stuff off, and I think I'm going to pull the tank. That's just going to be in the way. We'll get the stator pulled out and see what I can come up with for options here. This exhaust is a little interesting because usually there's a bracket right here that bolts to the stator end housing, and then the exhaust bolts to the bracket. So in this case, they omitted the bracket, which saves on a little bit of the manufacturing cost. Yeah, if there's any doubt that Generac made this, Generac always puts their tags right here. And the really interesting thing, too, is that the model number begins with PM, which is usually PowerMate, which Generac also owns. And the engine speed adjuster rusted to death. So the engine speed didn't sound off, but I'm not sure we could adjust it if we needed to. So I'm going to hit that, well, maybe with a bit of heat, but let's try to turn it as is. See if this is gonna budge at all. Not in the best of shape, but it came off pretty easily. So I'm just gonna clean it up, get some oil on it, and we should be good to go. Wow. This is like glued to the mounts, or at least rusted to it. There we go. And I'm going to get these off as well, and then we should be free to get the stator removed. All right, theoretically we're free. The only thing hanging us up is likely the ball bearing on the end housing, so I'm going to get a little bit of penetrating oil in there. And also the bell housing can as well. There's a little lip that the stator sits in, and if there is corrosion, it can kind of hold it in place. So let's, put a little penetrating oil right there. I might hit it with the dead blow hammer a few times just to try to break the seal. And then we'll use a puller to get it the rest of the way. Oh yeah, came right off. There is no obvious sign of failure on this stator. I don't see any burn marks, any hot spots, although I guess this slot right here has a little discoloration, but for the most part, this visually looks to be in really good shape. Anyway, I do have extra stators in storage. I don't know if they're the right size. Really, the big factor here is the length from end to end of the lamination. So I'm going to pull these two bolts out. That should allow the end housing to come off. And then we can get a really precise measurement of what we need. And then we can go check what we have. All right, let's see where this one comes in at. And it looks like we're a little bit over 5 1/8. It might be closer to 5 3/16. So yeah, let's make a trip to the storage locker and see if we have anything in this size. That one is too long. Too long. And to be honest, it doesn't surprise me. That stator seemed a little bit undersized. Too long. That was from the Chicago Electric. That's definitely too long. So, yeah, unfortunately. Oh, wait. We've got one more back there. Let's check that. Yep, that one's too long too. So there is another option back at the house. So let's check that out. So I think the plan is to steal the generator from this Generac GP8000E and put it here on the DeWalt. I mean, technically, we could probably make this one complete and skip the DeWalt altogether. And although the frame is in good shape, we are missing the handle, and the welds to hold the handle are broken as well. So it'd probably be easier just to harvest the generator and move it over to the good frame. But before we do that, I want to make sure this engine is junk. I'm told it is blown up. And the odd thing is that the engine actually has very good compression. So the connecting rod, it is not blown. It actually sounds halfway decent when pulling it over. And if we look here on the block, I don't see any damage. And that is typical if the connecting rod lets go. So potentially this engine isn't blown up. Although I say that, and I do see we have a hole right there. So likely something did blow up in the engine, although it would appear not the connecting rod. And of course we have no oil, and I think I see some chunks down there. So let's get the borescope in there and see if we can find anything in the sump that doesn't belong. All right, let's take a peek, see what we see. Yeah, and I see some chunks of metal right here on the oil fill. Let's go a little deeper, and yeah, that doesn't belong there. That is a cage for a ball bearing. You can actually see on the bottom, one of the balls are still present. And actually behind that cage looks like some more parts of the engine. So yeah, I'm not sure exactly what failed. Maybe we'll take a peek later. But if I had to guess, I'd say the balance shaft let go. So yeah, this engine, although it has compression, I would say absolutely it is bad. And, potentially could be rebuilt, but, as it is, we have a machine here that needs a generator. We have a good generator, presumably right there. We have a bad engine and a damaged frame. So this should be a fairly easy swap. Both engines have the Hemi head, but because the stator on the Generac is longer, the exhaust that came with the DeWalt isn't going to work out. But this one should bolt right in place without any modifications. So I'm going to swing this machine around. We'll start by getting the exhaust off, disconnect the wires, and just get the generator off of this bad engine. All right, you missed some of this. Well, actually, you missed most of the dewiring. So we only have the wire block left. And those bolts weren't very tight. And actually, the brush bolts weren't either. So that is a little concerning, but I think the odds of a bad stator and rotor and a bad engine are pretty minimal. But let's just check these real quick before moving on. So let's try to use the milliohm tester here to test everything on this generator. So we'll just probe one of the legs. Yep, looks like that one. So 0.238 seems good. No fault to ground. And no fault to DPE. So leg 1 appears to be good. Let's check leg 2. We should get about the same reading, 0.228. So yeah, very close. Check it to ground, no fault. And no fault to the DPE. So leg 1 and leg 2 would appear to be good. Let's check the DPE winding, which was the failure on the other machine. We should see between 1.5 and 2.5. And we're at 1.23. Seems good. No fault to ground. And then let's just check the sense. Yep. And yes. So this stator, it tests well. So let's get it off and move it on over. Not sure why that ball bearing was covered in so much dirt. Doesn't feel great, so yeah, we might have to replace this. Yeah, it doesn't sound very good. And there was a bunch of junk on here, so I think someone was trying to oil it to quiet this down, but it's definitely damaged. So I'm pretty sure I have a new ball bearing somewhere. Regardless, this one has to come off. So let's pull it off. And it probably goes without saying, but pulling on the outer race can damage the ball bearing or even break it. In this case, ball bearing is already damaged, so I'm hoping to use the outer race to pull it off the shaft. All right, I've got the old bearing out. Doesn't sound horrible, but it's definitely on its way out. So I did find another bearing, not new, but this one is super quiet. So I think we're going to use this one. I guess the only downside is that this ring right here, well, we're missing part of it, it appears. I've actually usually don't pull these rings out, so that might actually be complete. Let's check on this other bearing. And yeah, actually it's the same thing. It's like half a ring. So the point of this is just to help the outer race stay still and not spin. So I think we're going to be okay with the good used bearing. So let's get this pressed in place and installed on the DeWalt. Out with the old, in with the new. Well, let's get the slip rings cleaned up while we have easy access, and then we'll install the stator. Well, I'm hoping we're going to get lucky. This stator, it's about an inch longer, but the frame down here, it is slotted, and we were on the inner position, so we might have just enough to get this stator on without modifying the frame. So I think before I drive this in too much further, I'm going to get these mounts on to see if the existing holes are going to work out. And they're also needed to kind of level out the stator and just make sure both ends are at the same height. Yeah, we're right there. So I think the existing mounts are going to work out. So we get these reinstalled, torqued between 80 and 120 inch-pounds. And actually, before I do that, let's clean the outside of the stator real quick. Start with 40 inch-pounds and then bring it up the rest of the way. So I'm going to finish just torquing the mounts down to the generator frame, and then I'm going to pull the plug, and I want to pull the engine over, just make sure it rotates freely and that there is no scraping or binding between the rotor and the stator. All right, spark plugs removed. This should rotate freely. And the only resistance you should hear or feel is just the valves opening and closing. So it actually sounds pretty good down in the generator. So let's put over fast. Yeah, I think we're good. I'm going to move the bracket over from the GP8000 because we're going to use that exhaust. This stator, it's longer, and the one that came with this machine, well, the exhaust is shorter, so the mounts are going to be in the wrong place. So let's get the bracket on, get the exhaust on, and then we can do some wiring. And for now, I'm just going to leave this floating. You know, once we get the exhaust bolted in, we can circle back and torque these properly. All right, so all we need to do now is get these wires connected, and theoretically we should be able to make power, but I just wanted to call myself out on one mistake I made down here. When getting the end housing on, I did have to strike it quite a bit more to get the ball bearing fully in and the stator fully seated, which I kind of just wrote off initially as a really snug fit. But the issue actually was the way I installed the ball bearing. The one that came off was in this orientation, and when I installed the good bearing, I installed it like this, which, you know, theoretically it should work just fine either way, but the end housing, it is tapered, and because we put the ring further in, you know, it just made a much tighter fit. So if I were to do this again, I'd put the bearing on like that. Anyway, let's finish up the wiring and try this out. So we're going to give this a try with the new generator. Now, it should power up on its own. Tested well, but it is unproven. So we will find out in a minute, if this does make power. The other thing I've done is re-added the tank so I can plug in the fuel level sensor. And I've added a 12-volt AC transformer. And that is wired in right here. So the control panel should light up. And I guess my biggest concern, I think, is that my estimate of 12 volts might have been a little high. I crunched the numbers and we're more at about 10.5, maybe 11 volts is what this would have supplied. And this transformer actually outputs about 13.4. So hopefully it's not too much for this board to handle. So I'm going to get the engine started, assuming everything goes well. I might put on a light load and just see if we get any activity from the wattage meter. All right, let's give this a try. We're plumbed in again to external fuel. Choke is on. Contact. All right, that was pretty much perfect. Now, the engine speed, it was a little slow. I forgot that we pulled that screw out. So, I brought the no-load speed up to 61.5 Hertz. At that speed, we're at 119 volts, which was pretty much dead on. And more importantly, the meter works fine with a 12-volt transformer. Even when I applied the load, we saw the gauge just tick up a little bit. So I would say, the hard work's done. We need to get the end cover on, but I think I'm going to leave that off until we figure out exactly how we're going to wire this. And I guess we have the airbox as well. So I'm actually going to steal the airbox from the donor engine. That one is likely in better condition than the one we pulled out of here. So let's take a look at this airbox, the one on the blown up engine. The box that came on the DeWalt isn't in terrible shape, except for that piece of metal right up against the carburetor. So, we could reuse it and clean it up. But this one looks to be in much better shape and not serving any purpose anymore. So let's instead use this airbox. And actually, while we're here, let's just get the carburetor off, airbox off, flywheel off. Because once we finish up on that other machine, we're going to open this one up and see exactly why this one failed. I'm not sure where this came from. I just took the engine out, put it back on, and tripped over what looks like the inner race of probably the ball bearing that fell apart in that engine. How it got out, not sure. Anyway, let's start by removing the head, and then we'll open up the sump. Top end looks pretty clean. And I suspect, the cylinder head is probably good. Likely the piston, connecting rod, all the way down to the crankshaft. But we won't know till we get this apart. So I'm going to remove this retainer right here. We'll slide the pins out for the rockers. Those will come out as well as the studs. And then we'll pull the head bolts, get the head off the engine. Looks like the same Bosch plug on this engine. Yeah, cylinder head looks to be in good shape. So definitely a usable part. So the connecting rod definitely still connected. And the cylinder, I wouldn't say looks great. There is a little scoring down there, and there's a pretty good glaze going around. So there were a lot of hours on this engine. And actually the hour meter still works on this machine. It's only 5 years old, and it had 710 hours on it before the engine failed. Yep, it was the counterbalance shaft. Let's get those pieces out. So we'll get the camshaft out. Although it might be bound up. And I've got to imagine when that balance shaft let go, probably did cause damage to the cam and the connecting rod. Yeah, the cam is not coming out, so that's a problem. Anyway, that is part of the balance shaft. We have a much bigger chunk here and a piece of the oil sensor that got destroyed. So stuff is wedged in here pretty good. And that's the problem. We actually have a hole in the bottom of the engine. So yeah, that's where all the oil went. Usually when these go, they do punch a pretty big hole in the engine. I had a couple Predators a few years ago that 2 of them had an exploded balance shaft and just left massive gaps in the engine block. But that cam is not going to play nice. I'm not too worried about saving the crankcase or the cam for that matter. Just the fact that it won't come out tells me that something bad definitely happened to it. So I'm pretty sure on the other side where the journal is, that housing in the block must be destroyed because the cam, it should just come right out. Got it. So needless to say, I don't think this block is going to be used again. Right here, there is supposed to be a ball bearing that is missing. It's also broken. And if you look over here where the camshaft was being held in place, this is also broken on the left side. And it was kind of pinching the camshaft in place. Surprisingly, the camshaft doesn't look terrible. Decompression mechanism still works. And if you look at the lobes, the one here for the exhaust actually looks to be in pretty good shape. But the lobe on the other side did take some damage. And surprisingly, the journal that was fighting us actually looks pretty good. But the lobes are damaged, so unfortunately that cannot be used again. The oil sensor is completely destroyed. You can see the float right there. We have a bunch of shrapnel, pieces of ball bearing, and the odd thing actually is that we have a bolt, and I am not sure where that came from. We have a bolt for the oil sensor on each side. Those are still there. The connecting rod has bolts which are present. So this one can't explain where it came from. So maybe that caused this chain reaction because, yeah, something caused the balance shaft to blow apart. Potentially shoddy work, although this here looks like a bolt would fit right in it. Yeah. So what was that connected to? Not sure. Possibly right there. Yeah, that's where it went. So what came first? Did the shaft break in the middle? Or did this fly off, causing the destruction? Not sure. But the block, the counterbalance shaft, the cam, no good. Potentially the crank is good. We'll take a look at that in a minute. The cover, not good. There was a ball bearing there as well. And when taking the engine off the frame, this piece fell out, and I wasn't sure where it came from, but definitely fell out from inside the engine. So unfortunately, we don't have a lot of good parts here in the core of the machine. You know, the starter I'm sure is good, and possibly the piston. So let's get the connecting rod disconnected. We'll get the crank out as well as the piston and rod. Yeah, connecting rod definitely took some damage. This bottom bolt is very tight, and you'll get a better look in a minute, but it looks like that connecting rod got a lot of shrapnel striking it. And this engine was probably still running when this happened. So if it was running for a long time, you know, that could explain why there's so much carnage in here and so many little bits. The dipper's broken off too. So after this happened, if it was still running, it would have been starving for oil. Crankshaft actually looks pretty good. So I think it could be used. You know, it took a little hit right there, but nothing too concerning. The journals look good. Although the gears here did get chewed a bit. So I take back what I said. The crank is going to need a bit of work. And the connecting rod, definitely not good. It just got hammered. The journal, though, let's see what that looks like. Not bad. You know, a little something ran through it right there. But it doesn't matter anyway what the journal looks like, given the damage out here and the lack of a dipper. The piston rings are not stuck. There is a fair amount of scoring on the skirt. But the piston could probably be reused if you had to, although that looks like it got a little hot. So yeah, the parts here, not in very good shape. Yeah, it looks like even the bottom of the bore took on some damage. So this is a pretty extreme case of an engine destructing. And usually you can salvage something from inside. But this one, pretty much everywhere you look, there is damage. And I'm pretty sure this is the reason why. You know, this piece is usually cast and not bolted on. And of course, if this weight flew off, that would have caused all of this. So yeah, all these parts cannot be reused. But that's okay. You know, this machine still has a lot to offer, including the generator, which brought the DeWalt back to life. And we also now have an extra good tank and a whole bunch of other parts. So it's a few days later, and I got the part that I was waiting for. This is a transformer just like this one, AC to AC. The output's identical. And this one is potted, so it is weatherproof. And technically we can mount this anywhere. But what I'd like to do is put it behind the control panel. We do have a pretty good amount of space right in here. So let's do that. I'm going to start by drilling a few holes. We'll get it mounted, and then we'll complete the wiring and finish this machine up. So I don't want it too close to the box. So I'm thinking we should drill the holes right about there. So the first one, I'll mark with the punch. And once we have that one drilled out, we'll do the rest. And the transformer, it is going to be mounted in the back in the end, but you know, using it as a template on the front side is a lot easier. So we'll get all the holes drilled like this, and then we'll mount it on the back side. All right, so the transformer, it is nice and secure and out of the way. So all we need to do now is just wire this up. We have the 12 volt output, which needs to be connected to the gray wire. So we do need to open the control panel again. And I'm gonna pull these gray wires up into the control panel where we can join them to the output of the transformer. So we are gonna need to drill a hole to feed these wires as well as the 120 feed to the transformer. And this has a standard plug, so we're going to have to cut this off, you know, cut the wires to length and find a good spot in this control panel to tap in to feed the transformer 120 volts. So if we cut this zip tie right here, we should be able to tip this control panel a lot more forward. Yeah, that is a lot better. So now we have better access, so we can drill a hole right there. And actually, let's pull these gray wires up while we're here. So we'll cut this zip tie as well. And actually, let's disconnect the wires, or I should say the connector down here. And we should be able to pull these through. Now, my big concern is the transformer wires on the 12-volt output are really short. But I think we're going to be okay. The gray wires are just long enough. They actually make it all the way here. And the transformer wires, you know, we got a good 9 or 10 inches, so we should be good as far as connecting those together. On the 120 side, that might be a little more challenging. I need to study kind of where we can tap in. Obviously, any of these outlets we can tap into, but the screws, they're all on the side, and you can't really get to them like it is right now. So potentially, you know, we might tap into one of the outputs on a circuit breaker, but yeah, let's do the 12-volt side of things first, and then we'll worry about the 120. So we'll cut the cord, not to the final length, but just so that we can feed it through the bushing. Like that. And we can also fish the 12 volts through. So I think tapping into this 20 amp outlet is probably going to be the path of least resistance. We do need to, though, cut some more zip ties, because once we get those screws out, we need to be able to lift that outlet out of the way to gain access to the screws that are on the side. And there are a lot of wires that are going to be in the way. Wow, that was loose. Not a good sign. Let's check these others. And actually, they all seem good, so yeah. If that is loose, that's going to potentially create heat and arcing and power problems as well. So let's see if the bolt actually, or the screw, comes all the way out. And it doesn't. So I think we do need either a ring terminal that's cut out, kind of like that, or potentially maybe one like that. But I don't have one that is like this, but we can probably just use a standard ring terminal and cut it. You know, I think that'll make a better connection than one of these. I double checked the plug I cut off just to see what wire is what. Usually red or black is the hot wire. In this case, it is brown. And actually, I might put a little bit of shrink tubing on here first. All right, so the hard part's done. We just need to connect up these gray wires. So I'm going to cut them approximately right there. We'll strip them back and join them to the transformer. Okay, the wires, they are secure. Got some shrink tubing, which will shrink in place. And then I think we can just add some zip ties and close this up. We should be good to go. So I think we're at the point where we can secure the wires here in the generator. Get the end cover back on, get the tank fully installed. And I do want to try it real quick before bringing it outside, just to make sure that the transformer is working as expected. So we're going to secure these wires right here. They need to be secured. If you don't secure them, you risk them getting wrapped around the rotor. And when that happens, it pretty much takes out both the rotor and the stator. So you can't, or you shouldn't, skip this step. Before I get the tank back on, there is still just a little bit of fuel in there. And to get it all out, you really just need to pull the valve to get every last drop out. It's probably not a bad idea either, just to check the condition of the fuel filter. Yeah, a little gunked up, so we'll clean that out. And we got some chunks out, a little bit of water. So what I'm going to do actually is use this fuel right here to just clean the tank out. This has been filtered, so there's no chunks in it. Really, I just want to use it to wash out any debris that could still be floating around in that tank. I mean, ultimately, it's not going to matter a whole lot because the filter will keep it in the tank. But the more we can get out, I think the better we'll be. All right, so the fuel valve is reinstalled, and I think you may have missed this part, but I did pull the sediment bowl out just to make sure it was clean, and it was. So we'll get that back in place, and we'll clean up the bottom of the tank real quick while we have access. The top has already been cleaned, so that is ready to go. All right, let's give this a quick try. So the fuel line, it has been reconnected. The fuel valve is turned on. Choke is on. Contact. Well, I think we're looking pretty good. So like last time, the engine started right up, power came right on, and the new transformer seems to be working fine. Now, the runtime meter, that is really interesting. I've actually never seen that on a generator before. You know, if you're lucky, you get a wattage meter, which shows you the percent load. But to calculate the runtime, it needs to know how much fuel you have and also what kind of load is on the machine. So at no load, it was calculating 4 hours and 12 minutes based on the fuel I put in the tank. And of course, when we put this under load, it should recalculate that number to something much lower. So we will definitely check that out during the load test. So let's roll this thing outside and put it to the test. All right, it is the moment of truth. So will the Generac generator deliver the 7,000 watts that this machine is advertised at? I mean, it should. It came off a machine that was rated at 8,000 watts. You know, will the DeWalt engine produce enough horsepower to get to 7,000 watts? And a little more concerning to me is the transformer. You know, is that output going to be adequate, or are we just going to smoke the board? So those questions we will get answers to shortly. So I'm going to get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the voltage and the frequency. We also have the amp probe, which will tell us the total harmonic distortion. Now, anything over 5% can damage sensitive electronics. And on a machine like this, we're probably going to see in the 20% range. So, you know, that'll be interesting to see. This generator came off the Generac Power Rush model, which I've actually never tested as well. So potentially this one could be cleaner than most. We've also got the oscilloscope so we can see what the output looks like. And we'll use the load bank to apply the load. So, you know, once the engine's started and everything checks out, we'll bring on a 3,000 watt load. We'll give that a bit of time, and then we'll bring it up to the max rated of 7,000 watts. All right, so far so good. Engine started without issue. We're pretty much exactly at 61.5 Hertz, just above 120 volts. So we are pretty much perfect. And without a load, it's estimating 4 hours and 12 minutes. So it's a little bit hard to read. I'm not sure if that's gonna come through on video, but it seems consistent with what it said last time we had it running. And without a load, the THD is at about 4.3%. And the sine wave looks a little bit like a sawtooth, but fairly typical for machines like this. So let's put on a 3,000 watt load, starting with 2,000 watts, running nice and smooth, engine's holding speed quite well. Now we're at 3,000 watts, and the THD jumped quite a bit. We're now at 16.4%, and the sine wave smoothed out a bit. So let's take a look at the runtime meter, see what it says. And we're at 1 hour and 24 minutes. So let's give this a bit of time, and if there's no surprises, we'll go for the max of 7,000 watts. All right, no issues at all, pulling 3,000 watts. So let's bring the load up to 4,000 watts. No issues. How about 5,000, 5,500, 6,000? It's doing it. So let's bring it back to 6,000. How about 6,500, 7,000? Yeah, it's getting quite loud, but it's holding steady. THD is at 20.5%, and the sine wave is unchanged. So we'll give this a few minutes, and if everything goes well, we'll shut it down. Yeah, no issues at all pulling its rated load. So let's take the load off, and we'll give the load bank in the engine a few minutes to cool down, then we'll shut it down. Alright, so we'll shut the fan off and the master switch. Kill the light, and I'm going to shut the fuel valve off and just run the carb dry. Well, say what you want about Honda clones, but the best thing about them is that the parts, they are very interchangeable, easy to come by, and fairly cheap. And that is the only reason we were able to combine a bad Generac with a bad DeWalt to make one complete machine that is doing everything that it should. So, I hope this video helps someone. Thanks for watching.